Hi, I'm Alessandro Fail Garcia, technical marketing engineer at NGINX and the main developer of the core Ansible NGINX collection and rules. Today, I'd like to give you a brief overview and demo on how you can improve your NGINX workflows in AWS using Ansible's powerful automation capabilities. Let me start by giving you a brief overview of NGINX and why you might want to use it. For those of you that don't know much about NGINX, NGINX was created in 2004 and has over time increased in popularity as the fastest web server within the community. And don't take my word for it, there is plenty of benchmarks available online. As of today, it's the most used web server in the world, and as you can see in the graph included in the slide here, it's been steadily growing in popularity. If you'll forgive the pun, NGINX is very much like a Formula 1 car. NGINX is blazingly fast, and this is only possible thanks to a carefully curated engine, or codebase, and a lightweight encasing, around 8 megabytes on Alpine Linux. When you combine these two facts, you end up with a highly performant minimum latency, easy to deploy anywhere piece of software. And if you add into the mix that NGINX can also be configured as a reverse proxy, an API gateway, or a web application firewall, amongst many other use cases, well, NGINX becomes increasingly attractive. So, now that I've given you a very brief overview of NGINX, let's make a quick aside and briefly intro Ansible for those of you that might not have heard or used it before. In short, Ansible is an open source software tool for provisioning and configuration management. It is agentless, it only requires Python on your target host to properly work. It uses YAML as its configuration language, which you can see a short example on the image on the slide here. And more importantly, Ansible includes a wide array of modules and roles covering multiple use cases. Okay, so let's say I have X number of instances on AWS, and I want to deploy NGINX from them using Ansible. How can I do that? Well, you can use an NGINX role. Here at NGINX, we have 20 Ansible roles and counting. We have a role to install NGINX, a role to configure NGINX, a role to install and configure NGINX App Protect, a role to install NGINX Unit, and then we have 16 roles that accomplish various functionalities found in NGINX controller. In turn, we have two collections. The NGINX Core collection, which provides you with an easy way to install and configure NGINX Open Source, NGINX Plus, and NGINX App Protect, and the NGINX Controller collection, which provides you with an easy way to support NGINX Controller 3.x and later in your workflows. Both collections are available on both Ansible Galaxy and Red Hat's Ansible Automation Hub. For the purposes of the demo that I'll be giving later, I'm going to focus on the NGINX Core collection, although pretty much everything I'm covering also applies to the NGINX Controller collection. So hey, you've been reading about NGINX, you need a web server, a reverse proxy, or maybe, who knows, an API gateway, and you've decided to give NGINX a try. Or perchance, you're already a long-time user of NGINX, and just deployed a fresh set of EC2 instances on AWS. Why would you use Ansible to provision NGINX? Well, I hereby present you with 4 reasons. Number 1, you're already interested in Ansible, otherwise you probably wouldn't be watching this session. Number 2, in this day and age where decentralized, resilient, and redundant multi-cloud deployments are increasingly becoming more and more common, Ansible gives you the necessary tooling to easily install and configure NGINX across multiple AWS targets simultaneously. Number 3, moreover, by using Ansible as your source of truth, You can also achieve an unparalleled centralized insight into all your NGINX deployments, in addition to any AWS monitoring you might have already set up. And finally, number 4, both NGINX collections are certified and fully supported by Red Hat. That way, if something goes wrong, you will have someone to reach out and ask for help. Alright, cool. I've told you how easy it is to use Ansible to provision and configure NGINX. How about I actually show you in action? I'm going to give you all a quick demo showcasing some of the things you can do with the roles included in the NGINX collection. I've divided the demo into 3 sections. First, I'll install NGINX. Then, I'll configure NGINX to serve a simple web app and act as a reverse proxy. And finally, I'll set up the NGINX App Protect module to protect NGINX against injection attacks. So without further ado, let me dive into the demo proper. Cool, so I've gone ahead and opened up a terminal window, and the first thing you'll want to do before you start playing with the Ansible NGINX core collection is, well, install the Ansible NGINX core collection. You can do that very easily by running ansible-galaxy collection install nginx inc.nginx_core. Now, I've already gone ahead and done that beforehand, so I'm not going to do it again. Instead, I'm going to run a very simple playbook to check that the AWS EC2 instances that I deployed beforehand using Terraform have been correctly deployed. And while the playbook is running, since it does take a little time, we're going to go ahead and fast forward. Great, so as you can see, we have Red Hat, and Ubuntu, a CentOS, and a Debian EC2 instances. So let's go ahead now and deploy NGINX on those instances. To do that, we're going to use very simple playbook right here. Now in this playbook, I'm specifying that I want to use the NGINX core collection, and I want to use the NGINX role within that collection. The NGINX role is the role you will want to use to install NGINX open source and NGINX Plus. And for variables, which are the variables that I'm going to be passing to the NGINX role, I am setting NGINX type to plus to install NGINX Plus, and then I'm setting up the NGINX license path, and finally I'm specifying that I don't want to remove the NGINX Plus license once NGINX gets installed. So let's go ahead and run this playbook, and it's gonna again take a little time to run. Let's go ahead and fast forward until it finishes deploying. Okay, great. Looks like the playbook finished running and NGINX got correctly deployed. Let's go ahead and check real quick that it really got deployed correctly. So I've gone ahead and pulled up one of the public DNS URLs for one of the instances. As you can see, before running the NGINX deployment playbook, I could not reach the DNS URL. Let's go ahead and refresh, and voila, NGINX seems to be running right now. Even though there's no website configured as of right now. All you can see is the NGINX landing page. So let's go ahead and configure one such web page by running another playbook. This playbook, this time around, is using the NGINX config role, which is the role you want to use if you want to configure NGINX. Within this playbook, I am setting up NGINX to listen on port 80. Then I'm also setting up the default server name for this server block that I'm configuring here. I'm setting up the access log, and then I'm configuring some sub-filter data, which will be useful for demo purposes once you see the web page that I'm about to deploy. And then finally, I am setting up a location block within the server block that listens on all paths, hence the / nothing else, and then it serves the index.html file that lives within the user share NGINX HTML path. And finally, I am also deploying an HTML site that I am creating using the demo template configuration capability of the NGINX config role. All that is saying is that I'm gonna be deploying a website that lives in the same path that I specified beforehand as my web server path. And then I am using Ansible NGINX collection as my web server name, which in this case is a configuration variable that tweaks what gets displayed on the demo HTML page that I'm about to create. Let's go ahead and run this playbook. And again, let's go ahead and fast forward it to you until the playbook finishes running. Cool, looks like the config got deployed. Let's go ahead and refresh our NGINX website yet again to test whether it got correctly deployed. And there we go. As you can see, looks like it got correctly deployed. Right now I have a web page running here. The web server name is Ansible NGINX collection. You can see the private IP of the instance that is running NGINX. And some other data like the NGINX version, etc, etc. And but if I click as a refresh, nothing really happens right now since I'm only using a normal web server. So now let's go ahead and expand on our NGINX configuration to set up a web server with a reverse proxy in front of it. To do that, I am gonna start by creating 2 server blocks this time around, one listening on port 8008 and the other one listening on port 8009. Everything else is gonna remain the same as I just went through. The only difference is that this time around I'm gonna be calling the HTML files server_t and server_1, just so that they can be properly differentiated. And in front of those 2 server blocks, I'm gonna set up another server block listening on port 80. And this time around, instead of using the web server capability, I'm gonna use it as a reverse proxy. I'm gonna be setting it to listen on the / location, so again, it's capturing all locations. And I'm gonna use the proxy pass NGINX directive to pass any traffic coming to port 80 to an upstream group, which I am defining at the bottom here. Now this upstream group is gonna use the list connections NGINX method to load the balance between the 2 servers that I'm creating and setting to listen port 8008 and port 8009. And finally, similarly to the previous playbook example, I'm creating 2 demo HTML pages. One of them will now say that it's server 1 and the other one will say that it's listening on server 2. Let's go ahead and deploy this playbook. And fast forward until it gets deployed. Okay, great. Looks like it got deployed. Let's go ahead and refresh. And hey, it looks like it got refreshed itself. Since I was already auto-refreshing. Okay, good. So as you can see now, it's balancing between server 1 and server 2. And port 8008 and port 8009. Now the server address is not changing in this case because it's both web servers or technically running under the same instance. But that being said, you can see it's correctly switching between both. And you can also see that port gets correctly changed. Cool again. So, why not? Let's go ahead and finish the demo by deploying NGINX App Protect, because now that you've already seen how to deploy a reverse proxy in a web server, the next logical step is to secure your web server and reverse proxy. So I scroll up, and as you can see now in this playbook, I am also using the NGINX App Protect role. And I'm specifying some variables here, like I'm not setting up the license because I already did that in my initial NGINX playbook. I'm gonna be installing some signatures and thread campaigns in addition to App Protect. And then I'm also be using the configuration option, NGINX App Protect configure, to create a very simple security policy that by default uses the blocking enforcement mode. And then within the NGINX config role, I am gonna be loading the App Protect module this time around, and I'm also gonna be setting up some App Protect directives within my reverse proxy server block to make sure that any incoming request gets properly blocked. Again, let's go ahead and deploy this playbook. And fast forward until it finishes deploying NGINX App Protect, since that is going to take a while. And we're back. Looks like App Protect finally got deployed. Let's check real quick that nothing broke. And yep, seems like everything is still working. Yep, there we go. And to check that App Protect got correctly deployed, I'm gonna run a very simple playbook again that basically tries to query localhost within each instance, obviously, and pass along a script. Now, ideally, the script should get blocked if App Protect is running, because it's a potential injection attack. Let's go ahead and run this final playbook to check that App Protect is working correctly. Now this playbook should not take long. Alright, every test passed, as you can see here, which means that requests are getting properly rejected. And if we want to further test it, we can try to, let's write this in quotes. Try to replicate conjunction attack. Nope, there we go. And the request got rejected. So that's it as far as the demos go. And that's all I had to share today. I certainly hope you enjoyed the demo. Feel free to visit us at nginx.com/redhat if you would like to know more about how you can achieve secure, scalable, and resilient application delivery in AWS with NGINX and Ansible. You can also find us on Twitter, YouTube, LinkedIn, and other social media. Thanks again for watching this session, and I hope you have a great rest of your day.